On how to 3D print for part 3 of the assignment 1. So a little introduction, 3D printing is another additive manufacturing process which uses CNC machines which instead of removing material, they add material. So they require, again, G code or M code, which basically tells the head which is adding the material all of the XYZ coordinates and where to put the material. So the material is heated. Depending on the material, you can either print plastics or metals, and it heats it up to certain melting temperatures, and when it prints it onto the bed, it rapidly cools, forming your part. Now the part is formed up of many layers, so you can define how many layers and how solid you want the part to be, and this setting is called infill. So the lower the infill, the more hollow and less layers the material and part is going to be. The higher the infill, obviously, the more solid it's going to be, but that requires a lot more material and the print time is exponentially longer. So this is one of the main settings you can play with when 3D printing parts. You can also adjust the internal structure of the 3D printed parts, but today we're just going to use the general base setting of this software. Now the software, it can be very dependent on what 3D printer you're going to use, but today we're going to use Prusa Slicer. That's what I use at home. So the first thing we need to do is we need an STL file. To get an STL file, you need a 3D CAD part, so for example a SolidWorks part, and you need to do file save as an STL. So once you have your STL part, you drag and drop into the software, and you can see here is our 3D model part. So you've got lots of settings here. You can move around the part, you can adjust its scale, you can rotate it, but the best way to do is just place it onto a face that you want it to be the base of. So we're going to use the bottom of the part as our base, and you can see here, that's our part there, and this is what it's going to be like sitting on the bed of the 3D printer. So now we can move over to here, and you've got default settings which the software uses, but I've set up a 0.3mm setting, which is pretty suitable for the material that I use. So you can select 3 materials here. We're going to use PLA today. That's just the plastic that the 3D printer uses in rolls that you can buy. And I'm going to select infill of 20%. Because this is quite a large part, even at 20% infill, this print is going to be quite a long time. So as simple as that, you go down here and select Slice Now. So what this does is the 3D printing software slices it into all of the layers. So you can see here all of the different layers that the 3D printer identifies making up this solid part. Depending on your part as well, you may need to create bridges or supports. So for example, you can see here this small through hole through the top. It's quite small, but you can see here it may need a support structure to hold up that material because gravity, nothing's supporting that material. So when it's heated up, it's just going to droop down. But for larger components, this doesn't really matter because it's so small, but larger components, you will definitely need to do bridges and supports. So that's where your modeling skills come into play here, because you can't really 3D print parts that require large supports. It's just not very effective. There's just better ways to either model or create the part. So you can also see here, this is the time it's going to take to 3D print this part. So we're currently at 10 hours, 36 minutes, only on a 20% infill. If you were to adjust the infill to say 70%, it's going to generate the slice. And you can see here, again, a lot more solid with all those extra layers that infill the material. But the print now is 22 hours, 52 minutes, so it's more than double the print time. So this is not ideal. So we're going to go back down to the 20%. We're going to slice now. And you can see here, there's our part, a lot less layers, at 10 hours, 36 minutes. And it's as simple as that. You now export your G code. You locate where you want to save it to, and say on USB, and then send the USB over to the 3D printer, and it identifies the G code, and you can print away you go. Thanks for listening.